Hey everybody, Matt Morgan here. In this lesson, we're going to talk about stoichiometry and limiting reagents from Chapter 4 in OpenStax. In this lesson, we'll talk about stoichiometry, the mole method for solving problems, and then talk about limiting reactants. So another important topic is stoichiometry. It's a pretty scary sounding word, but all it is the relationship between the amount of reactants and the amount of products in a chemical reaction. Stoichiometry answers these questions. How much reactant do I need? How much product do I get? The key to stoichiometry is the balanced chemical equation, and we talked about that in the previous lesson. You will solve many problems using the mole method. What we need is the molar masses of the reactants and products, the balanced chemical reaction, and then our actual method is dimensional analysis. This next slide shows a map, a picture of the mole method. We can go between mass and moles of both reactants and products using the molar mass. We convert between moles of reactant and moles of product using the balanced chemical equation. Often when two reactants are mixed together, one will get completely used up and some of the other will be left over. The reactant that gets completely used up is called the limiting reactant. Textbooks will also call this the limiting reagent. So let's look at a non-chemistry example. Many problems involve determining what the limiting reactant is. So let's pretend we're given that a cheese sandwich is 1 piece of cheese and 2 slices of bread. There's our chemical reaction for our cheese sandwich. So how many sandwiches can you make with 6 pieces of bread and 2 pieces of cheese? And what is the limiting reactant? There's our equation. If we have 6 pieces of bread, there's 1 sandwich per 2 pieces of bread. We can make 3 sandwiches if we have 6 pieces of bread. If we have 2 pieces of cheese, it's 1 sandwich per 1 piece of cheese. We can make 2 sandwiches with 2 pieces of cheese. So which reagent produces the smallest amount of product? That's the cheese. In this example, cheese is the limiting reactant. We can make a maximum of 2 sandwiches. And there's an illustration. There's our bread, there's our cheese, there's our equation. We finish with 2 complete sandwiches and 2 pieces of bread left over. All the cheese is used up. That's why it is the limiting reactant. We can use this same process that we used for our cheese sandwiches to deal with chemical reactions. The ratios of reactants are given to us from the balanced chemical equation. To solve any limiting reactant problem, we will perform these steps. First, we will balance the chemical equation. We will convert the given reactants to moles. Then we will pick a product and find the amount of product formed from each reactant. That will require 2 calculations. The reactant that makes the smallest amount of product is the limiting reactant. Let's do an example using the reaction of hydrogen and oxygen to make water. That's the example we used in our equation balancing video earlier. There's our balanced equation. So assume we have 3 moles of hydrogen and 2 moles of oxygen. What is our limiting reactant? 3 moles of hydrogen can make how much water? We look at our balanced equation. We get 3 moles of water. Notice that we have the same coefficient both for hydrogen and water. Our balanced equation again. 2 moles of oxygen can make how many moles of water? That answer is 4. Notice that for every mole of O2, we get 2 moles of water. If we set this up like dimensional analysis, 2 moles of O2, which is given, our ratio is 2 moles of water for every 1 mole of oxygen. That gives us 4 moles of water. So which reactant makes the smallest amount? 3 moles of hydrogen make 3 moles of water. 2 moles of oxygen make 4 moles of water. The limiting reactant makes the smallest number of product, the smallest number of moles of product, the smallest amount of product. H2 is limiting in this case. And in this example, I think it's neat that there are actually more moles of hydrogen, but it is still the limiting reactant. So don't always pick the smallest amount of the given reactant. That's not always limiting. So to wrap up, you will use the mole method to solve stoichiometry and limiting reactant problems. You will be given the amounts of both reactants and asked which is the limiting reactant and possibly also how much product you will get.